Okay, now here is where the challenge begins. I want to show you how to compute it. I'm going to first put some lectures on the board, walk you through the steps. If you follow the slides that I'm uploading on Blackboard, it's taking you step by step into how to do this. Right now I'm going to walk you through the process. Remember that if you have questions, log into my live hour so you can ask any questions that you may have, alright? It can look somewhat intimidating, it can look somewhat difficult, but it's not. It's actually very simple. And I promise you one thing, if you know how to do this one, the independent samples t-test, the related samples are going to look like papita, piece of cake. This is the thing. We have to engage in the 5 steps of hypothesis testing. I don't have enough space on my board to write all 5, so I'm going to write 4, and then I'm going to tell you what the 5th is. The 5 steps of hypothesis testing relate to what you should be doing as far as trying to reject the null hypothesis. The null hypothesis, first of all, this is an independent samples t-test, so we're comparing 2 groups of different people. So I'm wondering how the fact that my classes go online is going to affect my statistics group versus my social psychology group. So I'm testing 2 different groups of people. Independent samples t-test. My null hypothesis is stating that nothing is going on. So null is like no. The null hypothesis is stating that neither one of the classes will be impacted by my online setup. Alright? The alternative is what we're trying to prove, so the alternative is what we want to see. If the null hypothesis is saying that nothing is happening, the alternative is saying that something is happening. My alternative hypothesis is that saying my students in both classes will be impacted. You know? When I say that something is happening, then that's my alternative hypothesis. That's the one that I want. Now, once I have this set, remember that it's key. What is super important is how you word this. If you use words that are saying that there's a difference, but you're not saying where the difference is at, then you're making this non-directional. Words that can be used could be impact, different, change, manipulate, affect, you name it. Those words are saying there's a difference, but I don't know where the difference is at. That would be called a non-directional, and that being non-directional, that would be two-tailed. It could be going on the upper end, on the lower end. An alternative hypothesis that is directional is saying that something is happening. If I'm going to say my statistics class are going to have better grades than my social psychology class, I'm implying that it's going to go up. That makes it directional. You can use words that could be going up, improve, accelerate, grow, better, you name it. Those words are saying there's going to be a difference and this is where the difference is going to go. Or it can also be negative, because you can say that perhaps my students in statistics are going to do worse than my students in social psych. So then I'm saying worsening, reduces, decreases, you name it. That would make it a one-tailed, and the one-tailed, if I'm saying that it's going up, is going to be a one-tailed positive. If I'm saying that it's going down, it's going to be one-tailed negative. Cool? To establish a criteria, when you have 2 different groups of people, every group, N stands for the amount of people that you have in your group, in your sample. So if I have 10 people, I'm going to have in the one group, say in the social psychology class, I have 10 students, 10 minus 1. In my statistics class, I have 20 students, so it's going to be 20 minus 1. I'm going to add those 2, that's going to give you my degrees of freedom. If you check your table, your t-table that I gave you last time that we met, the t-table needs to know the degrees of freedom, which is on the side. And then on top, it's asking you if it's a one-tailed or a two-tailed. Whether it's a one-tailed or a two-tailed depends on how you word this. Please remember that your alternative and your null hypothesis have to be almost the same except for the word not. If what I'm saying is gonna improve, and the other one we should say is not improving. If what I'm saying is gonna impact, the other one is saying is not gonna impact. Try to keep your words as similar as possible. The only thing that you should add is a not. And the not would go in the null hypothesis. So once I have my criteria set, it's gonna be degrees of freedom, taking into account both groups. Is it a one tail or a two tail? That's gonna decide if it's gonna be one level or the other one. And the alpha is the probability of error. The probability of error, if you want to get published, has to be at least 0.05. But it's really up to you. You can go lower than that. If you go over that, it doesn't really make sense because nobody's going to publish your result. Typically, the lower this number goes, the more difficult it is to beat the null hypothesis. If based on your research, you have a strong belief that whatever you're studying is gonna make a difference, then you can go at a lower alpha level. But if you're not too sure, then you gotta go to the standard 0.05. But it's really up to you. It's really up to the researcher. For now, we're putting this as an example, but it's up to you. Then based on the table, you're gonna decide what's gonna be your critical value. The degrees of freedom are going to be used on one side. On top, is it one tail or two tail on the table? And is it 0.05 or is it going to be anything lower than 0.05? You check the number, that's going to give you a critical number. So the T critical number is the number that we got to beat. Remember that if your hypothesis is negative, if I'm saying my statistics students are going to do worse than my social psychology students, my hypothesis is negative, then at that point I want to make this critical number a negative because I'm guessing that it's going to go low. And the number that you get in your t-test has got to be more negative than that. So just putting up numbers. I'm just making up numbers. If I put here like 2.5, just to say something, I'm saying my students are going to do better. I look at my table. Based on my degrees of freedom, based on my one tail, and based on my alpha, I'm going to say it's at 2.5 critical. Then I'm going to find here, I need to find a number that is bigger than this. If I'm saying my statistics students are going to do worse than my social psych students, then I'm saying that it's going to be negative because I believe that it's going to go lower. Then what do I need? I need a number that is more negative than that. I need something like minus 2.7. If I do that, then I can beat and reject the null hypothesis. Now, let's shift our attention over here. This is the thing that is somewhat tricky. This is the thing that is somewhat challenging. Look, what we gotta do is find the variance on both groups. The way to find the variance on both groups is actually fairly simple. We've done it before multiple times. We need to find the sum of squares. You know how to find the sum of squares. From each group, you find the mean, you subtract from each individual score the mean, and the number that comes out the differential, you square that. You add those numbers up, and that's going to give you your sum of squares. Sum of squares sum of squares divided over n minus 1 is going to give you the variance. So you're going to have variance for one group. It's going to be my variance for my social psychology group. And I'm going to find my variance for my statistics group. I have my variance for those two groups. Then, the pool variance is the headache. Because you have variance in two groups, but you want to glue it. You want to put it together. To put it together, you need to find a formula, a statistic, to pool the variance. It's called the pool variance. What you got to do is multiply n minus 1 from the variance of the first group, and you're going to add n minus 1 multiplied by the variance of the second group. So the number that you get here from one group is going to go here. The number that you get here from the other group is going to go there. And you're going to multiply that by the n minus 1 of each group. We divide that by n minus 1 plus from one group plus n minus 1 from the other group. And that gives us a pool variance. We're almost there. We're almost there. Once we find the pool variance, this is the estimated standard error. The estimated standard error is going to be found when you take the pool variance plug it here, the number that you get here, you're going to plug it here. You're going to multiply this by 1 over the sample size plus 1 over the sample size. Remember that first you want to take care of what is inside of the parentheses. So the first thing you want to do is you're going to take what is here. The number that you get here, you multiply by the pool. And then you take the square root over all of that. That's going to give you the estimated standard error. And once you have the estimated standard error, you're going to plug it in the denominator. And in the numerator, you're going to subtract the mean from both groups. So mean 1 minus mean 2. Say that in my statistics class, my students got a 87 of a mean. And in my social psychology class, they got an 82 of a mean. So it's going to be 87 minus 82 divided by whatever I found here. That's going to give me my t of obtained value. The number that I get on my t score, on my t obtained value, is going to be compared to my critical. If this obtained value is higher, then I reject the null hypothesis. If my number in the critical was negative, and the number that I get on my obtained is then more negative, I reject my null hypothesis. If my number is smaller, then it's the opposite, I would fail to reject the null hypothesis. You always want to reject, but sometimes the numbers are going to play in your favor. If you fail to reject, well, you try it, that's fine. But what you want to do is always try to reject. So whatever you're trying to look, whatever you're trying to research, make sure that you have a solid foundation to believe that there is a difference, because you go through all this work just to fail to reject, that sucks. Make sure that you do your research and you would have a better idea whether or not you're going to have enough to say that you can reject a null hypothesis. Now, the last thing is, once you do this, you're not done. You're almost there, but you're not done yet. You want to take in a measure of effect size. That's coming in the next video, so wait for that, alright? Out of this, if you have any questions, let me know. Good work.